This is Moses. He's a peregrine falcon and an expert flyer. The challenge for scientists today is to take all the stuff that Moses already knows and apply it to the field of robotics. Biomimicry is the process of solving complex human problems by taking inspiration from nature. Through evolution, nature has already solved many of these problems with incredible efficiency. So by copying biology, we can take advantage of the engineering which has already taken place over millions of years of trial and error through natural selection. To find out how animals are helping us to engineer robots, I paid a visit to the Bristol Robotics Laboratory, a state-of-the-art research centre based at the University of the West of England, home to hundreds of robots of all shapes and sizes, including underwater robots with whiskers.
So Mecha lobster only has one real sense, and that's the sense of touch, given by the whisker.
What kind of animals inspired this?
His leg designs were influenced by a lobster, although to be fair, he's kind of more influenced by mammals, really. An exciting one is the walrus. His eyes are situated slightly back from his head, so he can't really see that far in front of him. So he has to depend on his sense of touch with his whiskers. So he dives down to the seabed and he finds little shells. And his whiskers are so sensitive, he can distinguish what has food in and what hasn't. So imagine a 1.5 tons of animal, the size of a car, feeding on the tiniest little bits of food with his whiskers.
Why would a robot need a sense of touch?
A lot of underwater robots, they base their sense on cameras and sonar. But when you get up close, or if you're operating in Bristol Harbour, you're going to lose a lot of vision on your cameras. Even divers have to do things such as hand surveys, where they touch an object. So you need something that can actually define what they have felt. So this is where the robots come in. They want to start filling the jobs which are the dangerous, the dirty and the repetitive jobs, taking people out of dangerous situations. Because at the moment, only humans can do some of these dangerous jobs.
And is this made of anything fancy, or is the clever bit being done back here?
The whisker itself is quite fancy 3D printing, but this is all just dead material, just like hair, just like whiskers. So there's nothing interesting really up here. All the interesting stuff is back here. This is effectively a ball joint, and there's a magnet, and then there's a magnetic sensor at the back.
Amazing, so is that a reflection of nature?
Animals have whiskers and follicles at the end, and they have nerves wrapped around the end of the follicle base. So in some ways, this is quite inspired by nature.
So in the not too distant future, robots like Mecha lobster might be feeling their way around underwater using whiskers like a walrus. But how might we power these robots of the future? At the Bristol Bioenergy Centre, they're investigating one such alternative power source. So what exactly is a microbial fuel cell?
Well, a microbial fuel cell is like a battery. We have two compartments, the negative and the positive. And the negative side is where we have the bacteria inside. The bacteria eat the fuel that we feed them with. They're extracting the electrons from the fuel, and they're passing the electrons through the wire.
And it's the flow of those electrons that creates our electricity.
Exactly. And they're giving it to the other side, which accepting the electrons. And also they extract protons that they diffuse through the membrane. And here, because of the oxygen that we have from the atmosphere and the protons, they're producing water.
Amazing, so it's producing energy and water.
Exactly.
Now you mentioned you put a fuel in there.
Yes.
And now people at home might not know this, but there is quite a pungent smell in here. Could you tell us what you're using for fuel?
We're using urine in this lab actually as a fuel for the microbes to eat. So that's why this
You can definitely tell.
smell here. Yes, I know. You will used to it after a bit.
So how is this technology inspired by nature?
Actually, this is inspired by our own digestion system, where we have bacteria to break down the food and give us energy. Microbial fuel cells have great potential because they can be used everywhere that we have organic matter. It's not only urine, we can use also other type of fuels, wastewater, compost, food waste. Any organic matter can be turned into electricity through microbial fuel cell technology. That's why microbial fuel cells have a great potential in our world, because every day we're producing what we think waste, but for the bacteria is their food, and by that they can produce electricity, which is very useful for us.
So one day, inspired by the way that our digestive system provides us with energy, robots may be able to generate their own energy too, only with a slightly different diet. Earlier, we met Moses, who's been helping out a group of biomimicry researchers at the University of Bristol. But what can a peregrine falcon teach us about flight?
The project we're doing here is looking at quantifying the stability of a bird in flight. So trying to understand whether they're stable, which means they're flying along and they get hit by a gust of wind and they don't have to do anything and they'll kind of come back to nice and level, or whether they're unstable and they'll get hit by a gust of wind and they need to do a whole lot of corrective motions to stabilise themselves. So when we design something like a passenger jet, like a 747, we make them stable. But the most modern jet fighters nowadays are actually designed to be unstable, and they have to have incredibly fast computer-controlled control systems which do tiny little corrective motions to keep them in the air and controllable. Whereas a bird can move its wing geometry completely, and it can change from a nice stable configuration to a highly unstable one. So we're looking at where birds choose to position themselves on that stable, unstable kind of spectrum. So today we've been flying a peregrine falcon. He's actually been taking off from that hill over there and then flying past our array of cameras here, and they're all focused in on one single point in space. As the birds fly through that volume, we trigger the cameras, so we get 8 different views from 8 different angles. And with those 8 different camera views, we can get a 3D computer model of exactly the bird's wing shape as it was flying. So one of the other things we're looking at is how we might be able to use wing morphing on autonomous flying vehicles to be able to do the same sort of things we see the birds doing. So completely changing their flight dynamics by morphing their wings. Like we saw today actually, when they're coming in to hit the lure, he's actually slowing down a lot and doing this dynamic braking motion. And we'd love to be able to do the same thing with our aerial vehicles as well, kind of in the future, but have them coming in and perching and coming to a stop. That's kind of where we'd really like to take this research, is using it to inspire the design of morphing wing autonomous vehicles.
So clearly, there's a lot we can learn from nature. And I've certainly learnt a lot from meeting some of the people and animals who are helping us to engineer the next generation of exciting robots. A huge thanks goes to everybody at the University of Bristol, the University of the West of England and Bristol Robotics Laboratory who helped to make this video possible. A special mention goes to Dr. Corra Boushel, who helped to coordinate this project. She runs an awesome project called Robots vs Animals, so if you want to learn a little bit more about biomimicry and robotics, go and check it out at robotsversusanimals.net. Thanks for watching.